Right, guys. Let's just check everything's recording okay. Got the right volume. Yep. So, what have I been doing for the past 2 weeks or so? Well, I've been on holiday and I've been testing out, or my son and I have been testing out the print of the jet boat. And all I can tell you is building a plane is one thing, building a boat to be waterproof is another, altogether different proposition. So, what have we learned? This is a difficult print, more than you can think. Um, the thing about this, because it's dual walled, is it's prone to leaking, especially if your PLA layer height isn't probably lower than 2.25. It probably needs to be closer, a closer mesh. I'm pretty certain Sergey's used adaptive layering on his, and which this one is set to, you can see. Although I borrowed all these settings out for his propeller as well. So because you really need that for all these settings to get a really tight alignment on the mesh, and also to get the sharpest corner Z seam alignment, so you get a really smooth prop. So I've kind of left those in there, although I don't really need them for this hull. If you've got a printer tall enough, print it in one piece, because you will get, unless you seal it really well, you get leaks all, I tell you, you get leaks all over the place. Um, it tends to be porous, and it comes in from everywhere you can think. It doesn't really show until you start sailing it. So the solution to that problem, you may say, well, shall I use infill? No, don't bother with infill because it just wastes time on printing. Um, So, a few tricks before we start. To get this thing to lie flat on the bed in Cura, you can use this option and use that one, select face rather, to align to the build plate. So what you do is if I Control Z this, right? So because it drops it like this, which is obviously not what you want. So what you do is rotate it till you can see the face you want to drop onto the plate. Select the object, don't rotate it, but say select face to align to the build plate. Select that option and then click that face. Wait, with a bit of luck, because it's thinking about it. It should then drop it onto that face, hopefully. Yeah, come on. Do your job, man. I was doing it a minute ago. That's Gremlins for you. Presentation Gremlins. Let's try that again. Okay, right. Select and then select the face. Come on. Do as you're told, for goodness sake. Okay, select away, select face to align to the build plate, and select. Yeah, Kira's playing up. It's been doing this morning. Anyway, it works. All right, so I know it works. It's just Kira having a moment, and I don't want to restart Kira. So what? I'm just going to do Control Y until this thing's sat on the build plate properly, the way I want it. And it's sat roughly in the middle, which is where I want it. And I'm just going to zoom in here, and all we're going to do is have a good look at the construction of this thing. Let's just move that across to the middle. Okay, now I'll slice it. I've decided to go for a 2-wall count. Everything else is pretty much the same, 0.4, 0.25. I'm not changing the nozzle diameter. You can get everything done mostly with 0.4 unless you're doing very fine detail work where you might want to change your nozzle. I've gone for 3 top layers, 5 bottom layers, which makes sense because you want enough strength in um, the rear. I think they call that the stern, um, And you can see the benefit of having two walls is it is thick. Now, there's two reasons. You want it to be thick. Why? Because you want it to be strong, because it'll hit things. Um, and also you don't want any cavities. Any cavities. You want it to be sealed. That's the trick. Because initially I went for a two wall. I didn't use any infill. I relied on the fact that it's, you know, box section in places, and that it's two walls and that it wouldn't leak. Well, forget that. It will leak. Guaranteed it will leak, depending on how you've got your PLA set up. But even then, let's say it didn't leak, it's still not strong enough. I've got a boat which I bought on eBay, and it's ABS, and it is very strong, and it does not leak. And it's split this way in the hull. So, I mean, it's pretty much sealed the whole base, and then it's sealed between these two halves, top and bottom. And if I just scroll down here, you can see the benefit of having the top and bottom thickness is that the bottom thickness, if we just come right down to the bottom, again zoom in, there we go. And I got my brim. The brim also indicates it's flat on the bed. So you may say, well, should I have a brim on this? Probably don't need one because it's got a very big lower surface area. But what it does tell you is it's flat. If you've not got brim going around the whole object, it means it's not flat, which means you've got a problem somewhere. So I've got two walls. These engine mounts are important, so having two walls. When you push your rivets in, they tend to melt away, so you've got to use a soldering iron that's not too hot. That takes a bit of practice. And the walls are adequate now for filling this in. So even if it did have a small leak in the outer perforation, or there were some perforations in the outer skin, it's unlikely it's going to allow water to pass through. Plus, it gives some rigidity. Now, the other problem you have with this print is, and it is difficult because the design doesn't lend itself to printing very well vertically, is this wall here tends to have a gap down the bottom here. It doesn't show it here, but it will generally, depending on the material and how it flows and how your printer set up, it's likely you'll end up with a gap because where it's crossing over here, there's nothing underneath to support it, right? So you probably need to play around with the support blocker settings. And I might have a play with this, maybe do another video. Because I've definitely had holes here which I tend to fill with super glue, which isn't very elegant, but it works. This tunnel here, I'm pretty certain it leaks unless you've got this two wall. What happens is the back pressure from the propeller washes through the tube and it starts to leak through the wall. Again, that's the benefit of having the two walls. We sealed the entire hull with super glue, and yet there was still leaks coming through. So the only possibility of those leaks is either the wall itself is porous, possible, or the rivets, which we sealed as well, that you push in here, we're letting water in, we sealed those as well. So unlike an aircraft, you could have air leaking into the aircraft with your fuselage, but on a boat, you don't want any water leaking in because you've got electronics to deal with. So we soon found out that it's difficult. It is not easy, and I can see why Sergio spent a year getting this thing ready. The other thing about this design is it doesn't lend itself to putting lipos in there because you have to put the lipo forward into the nose, and that makes it nose heavy, which makes it want to sink, which means you've got to add ballast to the rear, which is pointless because then you're wasting energy because you're having to put ballast at the rear end to get the center of gravity to be roughly midship effectively. So other designs I've seen employ the batteries where they run perpendicular either side of the motor, and they have a clip over the top or a clip above, and they're using a couple of lipos side by side, which is fine, but then you're limited on range because only two, standard lipos aren't going to give you much range. So we were messing around with a short, stubby, 1500 milliamp hour lipo, and a relatively small 220 kV motor. The other issue with printing this area here gets a little bit fuzzy depending on your material and your settings. And I was saying about the water might be getting through because you have to put a seal in here. You have to fabricate a seal. Typically when I say fabricate, well, you have to use a bit of silicon tubing or something, both on the outbound and the inbound section, because it will let water in otherwise. We didn't have any water coming through here because I'd put a piece of tubing in here. We'd packed the hole in between with some oil, which is sufficient. You can put grease in there if you want. He pressurizes it with a syringe. But I have a bit of silicon tubing, fuel tubing from a helicopter, say, or aircraft in here, and on the opposite side I have a bit of tubing in there, and I make sure it's sealed either side. We were not seeing any water coming through here at all, so that's good. Um, but as I say, I think the trick with this is get your wall thickness right. You can test it in a bathtub in a static situation, but as soon as you begin sailing, then you notice the leaks coming in. The other thing with this design, which is a bit poor, I wouldn't say it's a poor design overall, it's a pretty good design, is that this really should have a lip here that sits out so that when you snap the hull in, water won't fall in through the gap here. So underneath here it does not supply a seal, he just leaves a groove in the two lids, but he doesn't provide a seal. So you've got to fabricate your own seal, either in TPU or get a bit of silicon O-ring of about 2.4 millimeter in diameter, and then cut it and put it, in the groove. Because it's critical you don't because you will get splashback as soon as you drop the throttle. Water, which was previously hollowed out behind the stern through the power, because it's drawing water through this tube here, where's my mouse? Through the tube here and spitting out the back. And the thrust is excellent, I have to say. But as soon as you drop the throttle, of course, the cavity that was at the stern, where all this power, because the boat's going forward, creating a cavity behind the back, suddenly backwashes forward and, as we discovered multiple times, fills up the back of it splashes over the stern into this area, so water's just going to pour down into the boat. So when you back off the throttle, you have to do it gingerly. So it really does need a seal, and I'd recommend, I don't know if Sergey's listening to this, or I'll drop in an email, but it probably needs an additional lip adding here. So there's a section here that stands proud by I'd say about 2 millimeters by 2 millimeters high, or 3 by 2 or something like that, so that it has a sort of box section that sits on top of here. So even if water did fall in here, it's not going to wash over into the main cabin area. Yeah, so that's the trick. The other thing is where you punch a hole at the back. If I turn it upside down, where you're going to punch a hole at the back to put the jet nozzle rudder, well, acting as a rudder, you need to punch it just beneath this top layer here. And to do that, what you do is you heat your wire and then lean it up against the top, but push it through from the back, and it will surface about here at the top. So you're going to mount the control horn onto the top of the arm, and you want it to be as high as possible. Why? Because as this thing planes, the thing will suck itself down and sink into the water, until you get on a fast plane, and then obviously it'll gradually lift out the water. But whilst it's on a slow relative plane, the water line tends to come up to about here, which is quite deep. Um, and that's all to do with the weight of the overall boat and the design of the boat, because it is short and stubby for a boat. We're going to look at redesigning this, I think, and lengthening the whole boat. We're going to create our own boats, but it's going to be longer. And that'll provide more capital, if you like, inside the boat for storing the battery and getting the battery down the side, or it wouldn't matter if it's further forward because it'd be long enough that we have more flexibility on the center of gravity. So that's the only thing I'd say about this boat is it's good, but it's very tricky to set up. The 1.5 um, 1500 milliamp hour battery, um, it sits just behind where the motor mounts, right? Because there's nowhere else to fit it. You can't fit it down the side here. There's not enough room. There just isn't enough room to put the battery in there because the 3 cells are quite fat. You could put a 2 cell in, but then you're not going to get the range. And you need about 12 to 15 minute range, I would say. Typical for a plane, typical for a boat. Recommended voltage, a PRM01 voltage transmitter, so you know what the voltage of the battery is, because what you don't want to do is run out of juice and then have to go and swim for it, or not bother, wait for the wind to blow it back. So all these things come into play. It's not a simple proposition, this thing to design, to build. It looks easy, it prints out relatively nice, but it isn't it's tricky. I can tell you, it's tricky. So we learnt a lot, a heck of a lot. So this print I'm doing now is going to be a 2 wall. All the set, as I say, I'm going to have 5 layers on the bottom, 3 layers on the top. The rest of it you figure out yourself, your PLA settings. I'm using some black PLA for another version of the fuselage, and 65 build plate temperature on mine, 102 flow rate, all the usual retract settings, which I've covered on all my other videos endlessly. And then adaptive layer, I say you only really need these particular settings for the propeller, but you may as well keep them anyway for this model. And that's it. When you're gluing, you just need to glue on this face. You don't need to glue on the nose, because this is where it's going to bond to. Just make sure you glue very well around the edges. You're probably going to need to put some secondary glue in here. And then you've got to print the nose also in 2-layer, wool rather. And where the hood dovetails into the nose, you may have to cut back the tang on the end to make it slots into it. But you also might want to check in that little slot where it goes in, where it's received inside, whether there's any holes in there that might let water come back in. So yeah, that's my penneth on this model. It does sail very well. It's very easy to control directionally. Probably the only thing I'm going to add to this design is a couple of bow plane plates at the back. Many boats tend to have either additional rudders. This doesn't need additional rudder because the jet motor provides adequate control. And the power coming out of this tunnel is phenomenal. It does take a little while to get the propeller into the center in the body that sits on the back of this. You need to put a little bit of tubing into where to act as a bearing, and when you need to drill these holes out a little bit to accept the rivet where you screw in the bolts. You may want to seal up around the entire jet body to stop water getting through, because water will either try to get through the body or it will try to get through these holes potentially. Um, Water has a habit of trying to get in everywhere, so sealing it is probably a good idea. Maybe a bit of silicone sealant around there, I would recommend, around the back of the body, and possibly some silicone sealant at the end of the rivet. You decide anyway. When you're putting these nuts in, you might want to put a bit of sealant in there as you're screwing them in, so you've got no chance of water getting through. Apart from that, I think that's it.